All right, this is going to be my third try. I'm trying to make a video for nonlinear motion involving making a graph of a circle or a portion of a circle. So number 2 on page 162, given a radius of 6 centimeters, write parametric equations and adjust your calculator to display a quarter circle between the positive x and y axes. So what we're doing is we're going to create equation, a circle, using the equations of 6 cosine t and 6 sine t. Now the 6 represents the radius of the circle. Since there's nothing being added to the end, then the center is going to be at 0, 0. And the t represents the angle, the variable for the angle that's going to be created. And then we'll be plotting a point every so often as we make a bigger and bigger angle. Let's adjust a window so that we can create a quarter circle starting at the x-axis. Now the x-axis is similar to what we call, or the positive x-axis is similar to what we call due east, or 0 degrees. So that's going to be starting at 0. And if we're only going a quarter of the way around, that would be up to 90 degrees. So the t is your angle measure. We're going to go from 0 to 90 degrees. And we're going to plot every 5 degrees. You know, you can use 3, 4, 5, 6 for your t step. Now I chose an x min and x max, x scale, y min, y max that allows me to square off the window so that when I look at it, it does look like a circle, or at least portion of a circle. And you can do that by going zoom square. So let's take a look at the graph. And there is our quarter circle. So I'm just going to I'm going to plop that quarter circle right over here as my answer. And it's also, the window is important because the window tells us, you know, the parameters that we stuck in for t. Now for part B, it says a half circle to the left of the y-axis. So that's going to be a circle that's over in this part, or a half circle that's over in this part of our coordinate plane. So that means our t is actually going to start at 90 degrees. And we're going to go up to 270 degrees. And again, step 5s. So let's take, and hopefully this is going to work. I'm going to presume it's going to work by putting the window measurements already over here. And let's look at the graph. Hey, fantastic. We got a graph that works, or looks like it was supposed to the left of the y-axis. What about a half circle below the x-axis? So I'm going to go to my window. If it's going to be below the x-axis, then that means it's going to be from 180 to 360 degrees. So let's type in 180 up to 360. And I believe that's going to work, so I'm going to plop that over there. And let's take a look at that graph. Surprisingly, we are on a roll. Now the last one is a little more challenging. I'm going to use the last one to demonstrate how we can find counterclockwise. This is not asked in problem number 2, but a counterclockwise graph from 0 to 270. So let's take a look at our window. Let's start at 0. Boom. And let's go to a positive 270. Let's just graph that real quick. Boom. From 0 to 270. And that looks really good. But now I want to create that, but in a counterclockwise fashion. So actually, let's change this. Instead of counterclockwise graph from 0 to 270, let's go 0 to a negative 270. Now to do that, think about some of the work that we've done in the past. Remember, a positive angle goes clockwise. A negative angle goes counterclockwise. So what we can do is we can change the t in our parametric equation to a negative t. And then let's change our t min to go from 0 to a positive 270 by 5. Now what that should do is that should create a graph from here, down to here, down to here, and all the way back up to the positive y-axis. So we're going to go counterclockwise by making our angle negative in the equation. See that again, see negative t, and here's our graph, and that does work. It goes from 0 to a negative 270, so I'm just going to drop that right there, and here is the window that coincided with that. Hope you enjoyed the video. Good luck with your parametric equations for nonlinear motion.